All right, so today we're talking, last thing for the week, on areas and volumes of similar solids. So we had talked about scale factor and perimeters, and we talked about when you got areas, you would just square those ratios, right? Oh, sorry, I'm getting tired here. Well, today we're going to connect it up to volumes, which is cubing it. Surprise, surprise. So it first says, are these two cylinders similar? If so, what's the scale factor of the first to the second? Okay, so we need to compare them. We need to compare the sides here and see, does 6 over 5 equal 12 over 10? Absolutely, sure does. So it is similar. And now the scale factor is any side over side. So we're going to take the reduced one here, and it's a scale factor of 6 to 5, or 6 over 5. Either is fine. So when you're looking at these, so we've talked about this before, the scale factor, A to B. And then we actually talked about the areas too. Remember, we said if we knew the sides were this to this, like 6 to 5, well, then the areas would be 36 to 25. That would be the ratio. Well, guess what? Volumes is cubed. So if it's 6 to 5, then it would be 6 cubed to 5 cubed. That would be the ratio of volumes. So when we look at what says, what's the scale factor of two similar prisms with surface areas of these? So we have a ratio here of two surface areas. So we have this going for us. We've got a squared and a squared. I need a scale factor. That's an A to a B. That's just regular. This is an A squared and a B squared. So what am I going to have to do to get to the A, B? That's right, we're going to take a square root of both. We take the square root of each of them, you get 12 to 18. So we're pretty much there. Please reduce it, divide them by 6. And you can either write it 2 to 3, or 2 to 3. Either way is just fine. Okay, and sometimes you got to work backwards to work forwards. So sometimes if I had said, instead of what's the scale factor, I said what's the area, well, then you might need to go back to scale factor only to go forward and cube them. Okay, and do 2 cubed and 3 cubed to get the volume ratios. All right. All right, 2 more problems. We are all set for the week. All right, the volumes of two similar solids are 120 and 250. Okay, again, I'm going to put them in here and just remind myself, this is volume. So we're talking A cubed and B cubed. That's what we've got going there. And it says the surface area of the larger solid is 250. Okay, so what is the surface area of the smaller one? So I'm going to go over here and do surface area. So larger one, I'm putting it, wait, is that right? Okay, okay, same numbers. Surface area of the larger one is 250. What's this one? But now they're talking surface area. So we're talking A squared and B squared here. So this is one of those situations where you have to go backwards to go forwards. Okay, so I have to first get this down to A to B, and then I'm going to have to get it to B, A squared to B squared. Okay, so first, and we can set this up similarly, but we first have to get this back down to just A to B. Okay, so to get this to A to B, I have to take the cube root of both of them. And once I do that, now I'm down to A to B, aren't I? I took the cube root, so now I've got my straight ratio. Okay, and now we're trying to set these equal and say, well, what are these? Well, you got to square them now. So now we finally have A squared and B squared here, and A squared and B squared here. This is a little tricky, isn't it? So those are now equal. We now have a proportion. So now I'm going to multiply and solve and multiply this over here. So I have 250 times this whole thing. So you can do this way too. You can do it all under 1. Okay, you can put the cube root and do the dividing in there and then just do the one big square. That's probably a little simpler. And I multiplied by the 250 because I wanted to get rid of it over here. So I multiplied both sides by 250. So go ahead and try it with your calculator. Do 128 divided by 250. Do that cube root button we talked about earlier. Square it. When you do 128 divided by 250, make sure you push equals after. Then cube root it. Then square it. Then multiply it by 250. And it should come out to a nice 160. Okay, because we can't bring this in. This is an a squared. I'm just going to back up for a second. A squared and b squared. So I got to get this guy to be an a squared and a b squared. Okay, so that's why I had to take they were cubes because they were volumes. So I had to do cube root, which brought it down to a's. But then I had to square them to get them to be a squared and b squared so that these would be similar. Okay, I can't set it a proportion equal until I have them likely, like the same. All right, last one is a marble paperweight shaped like a pyramid, weighs 0.5 pounds. How much does a similarly shaped marble paperweight weigh if each dimension is 3 times as large? Well, as soon as you see dimension, that is a scale factor. That is a length. And it's 3 times as large, so it's 1 to 3. That is like your A to your B. Okay? And it's saying that the weight is 0.15. How much does a similarly shaped one weigh if it's 3 times as large? So we're looking for the bigger one. So that means this one's the smaller one. But again, this is weight. So this is A cubed and B cubed. So right now they're not balanced, are they? So I need to go over here and cube these so that I can have both sides the same. And I'm just putting those little A's and B's in there for myself to help me remember what I've got going on and what I need to do. Okay, I'm not actually incorporating those letters into the equation at all. So I've got 1 over 27 equals 0.5 over x. Now we can just cross multiply and divide. So x equals 27 times 0.15, which is 4.05 pounds. All right, class. Feel free to listen to that again. I know that those last two especially are a little tricky. So just remember, you always want to have the same types of ABs. They're cubed or squared or plane or whatever, and you need to go backwards or forwards as needed. Square root, cube root, square, etc. All right. Have a wonderful weekend. God bless.